Alright, so you've just learned about sampling distribution of sample proportions. Let's put what you've learned into practice by looking at some examples. Now, whenever I'm learning something that's totally new, especially when I learn a lot of formulas, or in this case, I'm learning about these things called conditions that I need to check in order that I can actually make assumptions and make calculations, I want to write them down. So I wrote these down at the top, being able to describe my sampling distribution with the center, that mu sub p hat equals p. The spread is going to be sigma sub p hat, provided my 10% condition is satisfied. And then the shape is going to be normal, provided the LCC, the large counts condition, is satisfied. And chances are we're going to be putting those into practice. So I like to write them down just to get familiar with them, because we actually have to write these things out, show that we've checked them, in order to receive full marks on a free response question. Now let's go ahead and look. In this game of Scrabble, each player begins by drawing 7 tiles from a bag of 100. There are 42 vowels, 56 consonants, and 2 blank tiles in the bag, and we have a girl, Kate, that is playing. She chooses an SRS of 7 tiles. Let p hat be the proportion of vowels in her sample. Alright, so let's go ahead and mark the text here and see if we can't identify some things that are going to be important to us. The first thing that jumps out to me, and I want you to start paying attention to this too, anytime we see something about a simple random sample, that's going to reference a sample size. So we have a sample size lowercase n of 7. That usually means also that we have a population. Okay, does it tell us anywhere how many total tiles there are? And indeed it does. Up here we see that n is going to be 100. Now that's capital N for the population size. Okay, and then I see it tells me what p hat is supposed to be. What is it that I'm looking at as a sample proportion? So we let p hat be the proportion of vowels in her sample. So in that case, then I need to look at, well, what's p? What's the population proportion of vowels? And I see that there are 42 vowels out of 100. So that tells me that lowercase p without a hat, this is the population proportion, is going to be 42%, or 0.42. Now, let's go ahead and start answering some of these questions. First of all, can you calculate the standard deviation of the sampling distribution of p hat? Well, can I calculate? That tells me I should be checking some kind of condition. Indeed, I do have a condition to check standard deviation, and that's the 10% condition. So let's go ahead and check that. In order to calculate the 10% condition, we need n, which we know was 7, and then we need the population proportion. Oops, I'm sorry, we don't need the population proportion, we need the population size, capital N, where capital N was 100. And the question is our sample size going to be less than 10% of the population? Plugging those in, we can see that is 7 going to be less than 1/10 of 100? Well, yeah, because I can do this in my head. I can see that 100 divided by 10 would indeed be just 10, and so I know that that condition is going to be satisfied. Now, if you wanted to, you could stop right there and just put the check mark, but you do need to plug in numbers in this 10% condition in order for that to be satisfied. Okay, so to answer that question, we say yes, since 10% condition is satisfied. Now let's actually go ahead and calculate it. That's the sigma sub p hat, which we have that formula up at the top. Again, I like to write it out in my examples the first times I'm doing it. The more I write these formulas, the less I'm going to need a formula book. Also helps make sure that I am plugging things in correctly. So for sigma sub p hat, we get square root of 0.42, that's my p. Now 1 minus 0.42, I could plug that in, but I can also just do that in my head. And then again, I can think about, well, 42% are vowels, that must mean 58% are not vowels. Okay, and then my denominator, which is still inside the radical symbol, let me redraw that so it's nice and plenty big. My sample size is 7. Okay, I go over to my calculator. You're not going to see that on your screen, but you can punch this in, pause it if you want, no spoiler alerts. And we have 0.1865 for our result for the standard deviation of the sample proportion. Easy enough, right? It looks like a lot, it's a lot of writing, but we're just explaining ourselves, that's it. The math behind this is actually very, very simple, straightforward. We provided the formula, all we got to do is plug it in and evaluate it. Okay, let's go and look at part B. Is the sampling distribution of p hat approximately normal? Well, that's describing the shape, and we can see from up here, the very top right, we have to check the LCC, the large counts condition. So we want to know, is n times p going to be greater than or equal to 10, and is n times 1 minus p going to be greater than or equal to 10? Well, I have n and I have p already written out, so I don't need to re-record them. I can just plug right in. I do like to say that, hey, I'm checking my LCC here, and that is this formula up at the top. These two components, I need to check both, and again, we need to actually plug in numbers into these. So n is going to be 7, p is going to be 0.42, and we want to know, is this indeed going to be greater than 10? Well, this I might actually have to plug in and evaluate. Sometimes I'm okay without doing it. I can do it in my head, but I can't do 7 times 0.42 in my head, or at least I'm not sure that that number is going to be greater than 10%. If I stop to think about it, well, 42% of 7. That obviously is going to be less than 10 because 42% of 7 must be a number that's less than 7, and that is less than 10. Sure enough, when I punched this into my calculator, I got 2.94, and indeed 2.94 is not greater than 10. So, what does that tell us about the shape of the sampling distribution? We don't really know what the shape is. The only thing we can say is that it is not normal. No, it is not normal. The LCC is not satisfied. Next, what proportion of vowels would you expect on average from a sample of 7 tiles? Well, two big words there kind of tee me off as to what I'm supposed to do, expect or average. And again, when I'm thinking about average or expectation, I'm thinking about mu. But this time I'm looking at what's the average proportion supposed to be. So that's mu sub p hat, right? I'm looking at the sampling distribution. Well, from my formulas and my conditions, I know that mu sub p hat equals p. The nice thing about this is we proved earlier on in the notes, this doesn't require a condition. This is just true for proportions. We know it's an unbiased estimator. So the average sample proportion, mu sub p hat, is the same as the population proportion. I should expect 42% of any set of tiles, regardless of whether it's 7, 70, or 700, to be vowels. And that's it. Okay, so let's go ahead and take a look now at example number 2. Alright, so in this example we're going to put everything together, checking conditions, but we're actually going to use this to start calculating a probability and see if we start to have something that might be kind of a weird sample. Okay, so here first some housekeeping. Please go ahead and make some edits to this so that it actually makes sense. The original question here was talking about women that went on a diet, and I was like, man, that's kind of enforcing some stereotypes that I didn't really want to promote. So I changed it to a different stereotype that for whatever reason I guess I'm fine with promoting, and that's college students going around and partying instead of women going on diets. So trade in one bad thing for another bad thing, I guess. But let's move on. Sample survey interviews an SRS of 267 college students. Suppose that 70% of college students have been to a party within the last month. What is the probability that 75% or more of the students in the sample have been to a party? Okay, well, let's go ahead and first notice some key things. SRS of 267, again, just like that last one. Oops. This is going to be my lowercase n because SRS, we know that stands for simple random sample. Okay, now we see, suppose that 70% of college students have been to a party, 75% in a sample. So I have two different percentages here, and the challenge becomes, okay, well, which one am I supposed to use for P? Right, because that's what we're supposed to know. Like, I know that percentage is P, but now I also have this P hat, so which one's which? Okay, and the first thing I can see was probably 75% or more of the students in this sample have been to a party, and anything that references a sample is going to have P hat. It's a statistic, right? It's not P, it's going to be P hat. Okay? Now, the other thing I can see is that we are supposing that 70% of college students have been to a party. So this is a very common thing that we have to do, is we have to make an assumption about what is true. It's a claim or something like that. So anything that references a claim or an assumption is going to be considered truth. So we're going to call that our population proportion. That's P. Now, describe the sampling distribution of P hat for the proportion of college students that have been to a party in the last month. Well, describing a sampling distribution, it's like describing any other distribution, and that's doing sucks. Okay, so we have shape, first. And we know shape. It's either going to be normal or it's going to do something we don't really know. But if it satisfies the large counts condition, we know it's going to be normal. And we know that from the previous example, the LCC, that's taking the n times p, and that must be greater than 10. So we have 267 for my n, p is 0.70, and we want to know, is this greater than or equal to 10? And I don't know this off the top of my head, but I am very confident that that is true, because I know, hey, what's 10% of 267? It's 26.7. So that is obviously greater than 10, because 70% is more than 10%. So we're fine there. Now I have to do the other side of this, and we say what's n times 1 minus p? And that's 267 times 0.30. And we want to know, is this going to be greater than or equal to 10? Well, by the same logic, I can say that yes, that is going to be satisfied. So since both of these are considered satisfied, then I know that the sampling distribution is going to be normal. Okay, now we see what's the center. I can avoid u because sampling distributions are never going to have any outliers or anything unusual. They're always going to be a very specific kind of shape. Okay, they're not going to have any of those outliers or anything like that. We can just go ahead and jump right into C for center. And for center, we are looking at the average. So it's mu, but we're looking at mu sub p hat, the average sample proportion. And we know that that's going to be just p. It's from our formula that we wrote at the top of the page. And we know that p is 0.7. Okay, so now we know what our center of the sampling distribution is. Lastly, we look at spread. So spread does have a condition. We need to check the 10% condition here. And so the 10% condition says that our sample size, 267, needs to be less than or equal to 1/10 of our population. And we say, okay, well, what's capital N? I don't know. I don't have a number for capital N. I don't know my population size, but I do know my population. My population is college students. If my population is all college students, I have to ask myself, well, is 267 less than 10% of all college students? Well, reasonably, how many college students do I have? Thousands and thousands and thousands of them, right? But the question is really, is n going to be at least 10 times the size of my sample? Is it going to be at least 2,670? And we'd say, yeah, it definitely is. This is a double greater than symbol, and we use that notation to say much, much greater than, and that is going to tell me that my 10% condition is satisfied. So we are assuming that that's true, even though I don't know the value of it. I know that I have at least that many college students, and that's going to be fine. So that allows me then to calculate, oops, excuse me, I don't know what that was. We are going to calculate sigma sub p hat by doing this formula, p times 1 minus p all over n, and then taking the square root of it, where p is 0.7, 1 minus p is 0.3, and then my sample size is 267. Again, I'm not going to show you punching this in the calculator. That's something you can do for yourselves, but we end up with 0.0280. Boom, boom, boom. There we go. So now we've described our shape, center, and spread. Done, done, and done. Alright, so for part B, this one is going to seem pretty tricky at first, but I want you to put a star next to it, or maybe even a couple of them, because this is a very common AP style question for multiple choice. They won't ask it specifically this way, but it's going to ask you to calculate a probability, but much like what we saw with binomial calculations, it wants you to actually use a formula. It wants to check to make sure you can still do things by hand, maybe not necessarily carry them out. Okay, so we're going to remember what this is to actually work with z-scores and how it can relate to probability. Well, the first thing we have to remember is that, okay, well, this is going to be a normal distribution, right, from the description above. Center, our mean of that was 0.70, and the whole idea is to see, do we have a proportion that is, or do we have a sample proportion of 75% if the expected number is only 70% that go to a party. So this is what we want to know, right? Now, normally you guys would say, oh, just use norm CDF. Boom. No problem. It's done. We can figure that out. No problem. Okay? And we will do that in part C, but we're going to do it by using z-scores for right now. So we need to first of all remember that z is going to equal x minus mu over sigma. But we don't have x, we don't have mu, and we don't have sigma. We have mu sub p hat and we have sigma sub p hat. Well, guess what? Those are actually going to stand in because this x is really like an observation. It's going to be your p hat. Mu is just the mean of the distribution, but we are looking at the sampling distribution, so that's mu sub p hat. And sigma, well, that's the standard deviation of the distribution, the sampling distribution. We have this, so this all translates very neatly into this formula, where we have not x but p hat minus mu sub p hat divided by standard deviation of p hat. Okay, so now we can calculate by using a z-score, and what we really want to see here is to be able to use this notation, because this is how all the multiple choice questions are going to be presented to you, where we have the probability that z is going to be what? Well, what direction did we shade here, the left or right hand side? We shaded the right hand side, so that means we're looking at z-scores that are going to be greater than a certain value, and that value is all based off of this formula. So let's go ahead and just plug in to this formula, where p hat is going to be your 0.70 minus mu sub p hat. Oops, I'm sorry, p hat was supposed to be 0.75. My fault. That's going to be 0.75 mu sub p hat from the previous prompt was 0.70, and then our standard deviation, we just don't even want to use the 0.0280. We want to usually use the whole formula, because this is how, again, they are presented to you on the multiple choice part. And this is going to look really gross, but you're going to get used to it. And we're going to practice this a bunch more, so don't sweat too much about it, okay? And that is all over 267. And so this would be your multiple choice answer, right? Now, if you wanted to, you could go ahead and calculate this, plug in this whole fraction here, and you would end up with a z-score of 1.78. And when we go to our z-table to re-look at that, I'm not going to do it for you right now, but you can just trust me on this, that the answer is 0.0375. Now let's use norm CDF to actually verify this, because this is going to be how you're going to do it for most like multiple or free response questions. Okay. Now, in order to use norm CDF, it's the same thing that we have here. Okay. So the first thing we enter in is our lower bound. Well, what's the lower bound of this shaded region? 0.75. And then we're looking at the right hand side. So what's my upper bound? This is my lower bound. My upper bound is going to be positive infinity, because we're going in the positive direction, right? And then we say, well, what was the mean? The mean was the number that was in the middle, and that was the 0.70. That's mu sub p hat. And then we need to enter in the standard deviation. This is where we can actually enter in the calculation that we did before. So that's sigma sub p hat. Okay, punching this into our calculator, we get something very, very similar to what we saw by using the z-table. That's always a little bit different just due to rounding error, but we get 0.0371. Okay, so what does all this mean? It means that if we were to assume that we have 70% of all college students went to a party in the last month, I take a sample, 267 college students, how likely am I to get something that's a little bit different, like say 75%? And we say that I only have a 3.7% chance of getting something like 75% or even more extreme. So if I were to get a sample of 75% at my college campus, I'd say maybe I've got a little bit more heavy of a partying kind of campus, because this was really, really unlikely to occur. Okay, so I want you to use these examples, watch the video again if you need to, and try to answer the remaining questions. I will have my key posted for you guys to look at, but don't just copy stuff down. Really try to read it, try to dig into it, and make sure you get the homework practice done. I promise you the stuff that we do in examples and homeworks is very, very similar to our test. Thanks guys, have a wonderful day.